compiler, and hopefully you've got one of these in front of you, or you recognise it, and you've made one of these knowledge organisers before. What we're going to do now then is do the important bit of this, which is testing our knowledge, and it's that testing of the knowledge that's going to help commit things to our long-term memory. So you've got 2 minutes. I want you to have a quick look at your knowledge organiser, do read, cover, recite, pause this video now while you do that, and then we're going to move on to a couple of quizzes, and then onto an exam question, and look at how people did nationally with that. Alright, so pause now. Let's move on then to our first quiz, which is looking at making monoclonal antibodies. So this was the first section of our knowledge organiser. I want you to look at these boxes, A, B, C, D and E, and I want you to think what words are underneath those boxes. So pause now. Alright, answers coming up. So underneath box A was B lymphocyte. So when we're making monoclonal antibodies, we inject a mouse with the antigen and we're looking for the B lymphocytes. They're the type of white blood cell that make antibodies. We need to combine that with cell type B, which was a cancer cell. And then we combine them together genetically to make a mixture of cells called a hybridoma. Now we've only got one hybridoma cell probably, so we need lots of hybridoma cells and we need to clone it. It was important that we use the word clone. And when we've got lots and lots of them, we can extract the antibody out of the liquid, but the key here is that the cells are all identical. So they're identical cells making identical monoclonal antibodies. Let's have a look at our next section then, which was testing, and it was based on pregnancy tests, but it could also be used for a COVID test. There's a question coming up where we're looking at anabolic steroids. So have a look at these 4 boxes, see if you can work out what the words are underneath. Pause the video now. Alright, we're going to go through the answers. So in a pregnancy test, the urine is put on the pad of paper at the start. The urine could contain the antigen, which in this case is a hormone. So the free antibodies will bind to the hormone and they've got a blue dye attached at the other end. So the free antibodies, these can move, but they've got a dye at one end and they attach to the antigen. They move down the sample where they bind onto immobilised antibodies. So the immobilised antibodies are stuck onto a test strip, often in a line. On pregnancy tests sometimes they write yes in antibodies, so that it spells yes in blue dye. So as the free antibodies with the antigen attached to the immobilised antibodies, so does the bead, so we see a blue line. So a blue line in the first window is a positive test. It then carries on going down through the paper to a second set of immobilised antibodies. This is the control. And so if the test has worked and all the antibodies have made it all the way down, then you get a second blue line. Let's look at the next one. So this was the bottom half where we used monoclonal antibodies in a negative pregnancy test. So this time there is no hormone in the urine, so there is no antigen. That means the free antibodies don't bind any antigen. What went here then? There was no antigen to attach, and so the free antibodies didn't attach, which meant there was no blue line in the first window. They should, however, carry on, and they should still attach to the second line, because the second line has antibodies complementary to the dye or to the controlled end of the antibody. So there should be one line, but in the second window. Let's see then if that's helped with some more questions following a similar trend. So here we've got other uses whereby we've got a monoclonal antibody attaching a toxic drug. So this was used to treat cancer. And it works by attaching a toxic drug there. And what were these here on the cell? This was a cancer cell, and these were molecules on the outside, so they were cancer antigens. We can also use them in other diagnostic cells, so we can put them on slides, or we can put cells in pots, and we can squirt on the monoclonal antibodies with a dye, and they only stick to cells with that substance, and so you can see where the dye is. Let's have a look then at some exam questions. Question 1. What type of cell is created when a mouse lymphocyte and a tumour cell combine? Embryo, hybridoma, phagocyte or stem cell? Which one do you think it is? Chances are you're right, because I've got here the examiner's report, and you can see that 92% of students correctly identified hybridoma as the cell. So this was one of the easier questions. Describe how scientists make monoclonal antibodies using the cell created when a mouse lymphocyte and a tumour cell combine. So it's telling us that we're using a hybridoma really in the question. What else do they need to do to make it for 3 marks? Pause the video and have a think. Alright, answers are coming up. Here's the mark scheme. You've got a mark for saying the cell is cloned, and you had to use the word cloned. It was underlined. Many identical cells are produced, or many clones are produced. And because they're the same, they all make the same antibody. And the last mark could have been for the antibodies collected and purified, so any 3 of those. Let's see how people did nationally. Let's look at the examiner's report. Alright, so here's the examiner's report. This question was much harder. Just under 3% of students were able to get 3 full marks. So, because lots of people put hybridoma is formed when a mouse lymphocyte and tumour cell combine, it gained no credit as it had been assessed in the previous question, and so wasted time and space. Very few described that the hybridoma is cloned. They said it divides by mitosis and got no credit. Additionally, very few were able to describe that all the cells produced made the same antibody. The most common point made that gained credit was that monoclonal antibodies need to be purified after collection. This question was set at a high demand and required the correct use of terminology, to which very few students were able to do. Almost 59% of students scored 0 marks. So this was a hard question. Most students got no marks. 97% of students didn't get full marks. Okay, on to the next one. What property makes a monoclonal antibody useful in detecting the presence of an anabolic steroid in the urine? So which one of these is it? A monoclonal antibody is quick and easy to produce. A monoclonal antibody is specific to only one person's urine. A monoclonal antibody only binds to an anabolic steroid. Or a monoclonal antibody can identify many different drugs at the same time. Pause the video if you need to. And the answer was this one. Monoclonal antibody only binds to the anabolic steroid, so it's the 3rd one. Let's check the examiner's report. And the examiner's report says that 90% of students could identify this. So this was going back to easier questions. Describe the evidence in figure 2 that shows the test for athlete B has not worked. So we're looking at this test strip here, and there are no bands on it. The first band isn't blue, the second band isn't blue. Suggest one reason why the test did not work. So you're going to say what the evidence is, and then you need to give the reason for it. Pause the video now. What would you put? Alright, I'm going to have a look at the answers. The evidence was that there was no visible dye in the control area. So here, this one's the control area. The reason there was no visible dye is because no free monoclonal antibodies bound to the area, or the free monoclonal antibodies didn't move up the test strip far enough, or the urine didn't move up the test strip far enough. Some of you might remember from the COVID days and from the lateral flow tests that sometimes there wasn't enough buffer in its saliva, the sample that was used, or the nasal swab, and you didn't get a positive control. Let's see how many people got that right then. Many students were able to give correct evidence, with 58% gaining 1 mark. Sadly, less were able to suggest a possible reason for the evidence. Only 26% of students gained both available marks, so they could give the evidence but couldn't say why. Some students referred to other processes involved in the test when discussing the reason, rather than focusing on the idea of monoclonal antibodies not binding to or reaching the control area. Alright, last question. Using the same 4 tests, which athlete had tested positive for steroids in the urine? Nice easy one. The answer was D. Let's see how many people got that right. 75% of students got it right. So in order to test positive, this is the test window, so you need a line there, but you also need the control window to work, which is why A isn't right, because although the test window worked, there was no control, which means the monoclonal antibodies hadn't bound down here, or the dye hadn't made it, or the monoclonal antibodies hadn't made it that far. And that means that that doesn't count. Right, well done. Hope you enjoyed that. On to the next one. I'll see you next time.